For my special project, I decided to study the hydroelectric power plant at Kalene Hills, Zambia. I will also explain how it works and its effects on the community. Before the hydroelectric dam came into Kalene, the locals cooked on fires and the hospital ran a diesel generator for 3 hours every day to supply the missionaries and the hospital with power. However, transporting the diesel hundreds of kilometers was very costly and inefficient. One solution to this problem is to build a permanent power station. This is what Dan Ray, an English engineer, did. He helped design and oversee the building of a hydroelectric dam. Since bringing materials to Kalene can be prohibitively expensive, the people building the power plant built the canal walls, weir, and powerhouse using stone masonry. This also created over 400 jobs for the locals, with half being women. This was a big deal for the area because men were normally the ones to work, and a gender mix was unheard of. In some sections of the hydro plant, like the middle of the canal and under the powerhouse, there was granite, which they had to blast with dynamite to make room for the buildings. The builders then took that stone and used it to build the powerhouse walls and the weir. This meant that only a fraction of the materials needed to be shipped to Kalene. The water, flowing down the river, reaches the weir. The weir then diverts a portion of the water down the canal. The rest of the water goes through the weir and down some rapids, until it rejoins with the water that went through the turbine. The purpose of the canal is to maintain the water level at the weir to the head pond. The first part of the canal, the settlement pond, which is wider and deeper than the rest of the canal, is used to settle the silt in the water. At the bottom of the settlement pond wall, there is a hole which lets through water that carries the sediment. If the sediment was left in the water, it would damage the turbine, making it less effective. The rest of the water continues down the canal and goes into the head pond. From there, the water goes rushing down the pipe into the powerhouse to spin a turbine. You may notice that there is room for a second pipe. This could be implemented, however there is not enough water in the dry season for even one turbine. Adding a second turbine would not be smart. If they added a second turbine, there could be months without power. Inside the powerhouse, the water goes through guide vanes and into a turbine. The guide vanes control the amount of water going into the turbine. The water then spins the turbine and exits through the floor and out the draft tube into the river. The turbine spins an axle connected to a gearbox. The gearbox ramps up the speed and turns another axle. This axle has a flywheel attached to it, which stores energy. This stored energy means that when there is a sudden need for electricity, it can be supplied easier. The axle that the flywheel is attached to is also attached to a generator. The generator turns the mechanical energy of the spinning axle into electrical energy. A device then compares the amount of energy supplied to the demand for energy. If there is excess energy, this device will close the guide vanes. If there is a demand for energy, it will open them. From there, the electricity is transformed to 33 kilovolts, or 33,000 volts, and sent to the rest of the houses and businesses. To make the model, first I cut out the outline in cardboard. Then I made the powerhouse and canal walls out of cereal boxes. I added the cardboard weir and styrofoam for under the ground. I then put paper mache on top of the styrofoam and cut out some styrofoam for the water in the canal. Finally, I painted it all with acrylic paints to make it look good. I made the inside of the powerhouse using cardboard, tape, and rolled up paper. I made a bunch of small boxes for the machines and rolled up paper for the axles connecting them. I use tape to hold it all together and paint to make it look pretty. Now that there is electricity in the area, the hospital can help more people by being able to work later and use more and better equipment. It is also easier for the missionaries to contact their supporters and help more people in that way too. Having access to electricity also means that people can use cell phones for much cheaper, can cook on electric stoves, and have lights in their homes, all of which improve the quality of living. However, as the amount of consumers grow, the amount of available electricity goes down. Dan Ray hopes to build a reservoir upstream to hold water for the dry season, but that could be in 5 years and will cost a lot of money, so it is very unlikely to happen soon. I have had the honor of talking to experts like Dan Ray, Sam Phillips, and James Atkinson, and also being able to be inside the powerhouse and see the machinery. Learning about the hydro dam has really increased my understanding of how power plants make electricity and the sort of work that goes into them.